Alright, this is the last video lesson before the vacation on Concept H for regions. This is the very end of Unit 7 for you. Honors will be continuing for a couple lessons after we return from vacation. So we're basically going to be combining what we've done the last couple of lessons. Because in a lab, we can't actually measure specific moles. We've talked about this. We can only measure in grams and volumes. However, when we look at our chemical equations and reactions, those occur in mole ratios. So we have to be able to relate moles to grams and volume. So say we need to produce 18 grams of hydrogen gas in order to proceed with the next step in an experiment. How many grams of zinc will we need to react? Well, we can relate different reactants and or products using dimensional analysis. However, our second conversion factor is going to come from the coefficients in the equations. What makes this type of question different than what we've done so far is, before we've only worked on one side of this. We worked with the same exact compound or element throughout all the calculations. Now we're relating two different elements or compounds, either two reactants or reactant and product or two products. Alright, so if we need to produce 18 grams of hydrogen gas, we need to know how much zinc we need to react. So we're always going to start with our given, which is 18 grams of hydrogen gas. For these calculations, you have to show the element or compound with the unit. So please make sure you're going to be writing down in this question the hydrogens and zincs. So going from what we've done before, I have grams of H2, so it means I need to have grams in the bottom, and I'm going to relate that to moles. So here we're converting from grams to moles. So if I were to stop here, my answer would be in moles, but we need to keep going, because right now I also have it in hydrogen when I need to get to zinc. So the next conversion factor, which is our second one here, is going to relate and use the coefficients, just like we've done in previous mole calculations. So 1 mole of hydrogen gas, using the coefficient of 1, is equal to 1 mole of zinc that's needed. And then finally, we need to get from moles of zinc to grams. So we're going to go ahead and do 1 gram of zinc is equal to the 65.4 grams of zinc, which is the GFM for zinc. So we've gone from grams of hydrogen gas to grams of zinc. One of the big parts of this that's new is being able to use the mole ratio in one of the equalities. We can cancel out the repeating units in the numerator and denominator, so I'm left then with my answer of 588.6 grams of zinc. Alright, so how many grams of water are formed when 8 grams of methane react? Methane is CH4. So again, I'm going to start with my given, which is 8 grams of CH4. I then want to go from grams to moles of CH4 so that I can relate that to water. So here I'm going from grams to moles. So 16 grams of CH4, which is the GFM, is equal to 1 mole of CH4. Alright, this is our second equality that we're going to be plugging in. So remember, this is where we relate the two. So 1 mole of CH4 is equal to 2 moles of H2O. And again, I'm taking that from the coefficients up at the top. And then we can go ahead, now that we have moles of water, we can now get to grams of water by using the GFM. So 1 mole of H2O is equal to 18 grams of H2O. So the repeating units in the numerator and denominator can get canceled out. So I'm left with my target or my goal for my unit, which is grams of H2O. If I carefully multiply across the top, divide by anything on the bottom, I get 18 grams of H2O that is needed. Alright, how many liters of oxygen are needed to produce 216 grams of water? The only difference here is that we're talking about oxygen in terms of liters, but we can just use an extra different conversion factor at the end in order to take care of that. So as always, start with your given, which is 216 grams of water. We then need to go from grams to moles of water, just like we've done in our other calculations. So 1 mole of H2O is equal to the GFM of water, which is 18 grams. Now that I have it in moles of water, I can go and relate this to moles of oxygen using the coefficients from the top. So 5 moles of oxygen is equal to 6 moles of water. And again, that's coming from the 5 in front of O2 and the 6 in front of H2O. Now that I've gotten my answer into moles of oxygen, I can go ahead and relate moles to liters of oxygen using the 22.4 liters. So 1 mole of oxygen is equal to 22.4 liters of oxygen. So carefully multiplying across the top, dividing by the bottom, and also canceling out the units that are in the numerator and denominator, we get to our final answer, which is 224 liters of O2. Alright, so just go ahead and write your summary. I would focus on what makes this type of calculation different than what we saw in our previous two concepts, and then summarize from there.